Hello, this is Mrs. Boots. In this project is our polynomials. You are going to design your own roller coaster. Okay, I know, craziness. I hope you like roller coasters because this is how they actually design them. They pick a curve and then they look at their structural constraints. Can we build it that high? Can we build it that long? Do we have enough space? Usually they start with the constraints first. We know a max height and a max length. So that's where you're going to start. Your units are in feet per second. That should make things easier. Your maximum height is limited to 300 feet. It can be less than that, but it cannot be more than that. You can't do loop-de-loops because your polynomials aren't going to model that. That's in another lesson, okay? You have to have at least 3 hills. What's a hill? Okay, it's got to go up 3 times. Now, if you look at roller coasters, the first hill is always the tallest. So you want the first hill to be the tallest, and then you have your second one and your third one. The last constraint is that you want your ride to be at least 3 minutes long. Those people stood in that long line waiting to get on your roller coaster. So don't make it short. Make it a nice long roller coaster. 3 minutes translates to 180 seconds. So make sure when you design your polynomial, you have 180 seconds worth. Now, I've given you a table and I've given you graph paper. So you need to write your equation, create a table of values. No, there's not 180 rows in that table. So maybe increment it in 50s, 10s, 20s, something like that. The same thing when you graph it. Don't graph every single point. Graph it in increments of 20s or 50s. But you do have to graph your polynomial. You have to clearly show the top of your first hill, top of your second hill, top of your third hill, and that it exceeds 3 minutes or equals 3 minutes. And that is your design project for this unit.